Alright, in this next video, we're going to go ahead and extend the concepts from the last video where we talked about solving an equation, and we're going to extend it to formulas and solving for an indicated variable. Okay, when solving for an indicated variable, this means that we are going to have equations that contain multiple variables or multiple unknowns. And what we want to do is we want to treat everything that is not the variable we are solving for like they are constants. We want to use the techniques that we talked about previously for solving equations in order to isolate the indicated variable. One thing to note is as you work on these problems, and especially as you work on your homework online, is make sure that you use the same version of the letter throughout your problem and in your answer. If the original problem has an uppercase T, then you need to make sure that you use an uppercase T in your work and your answer. If you type the wrong version of a letter in the program, it will be marked wrong. And just to let you guys know, in many math and science classes or anywhere where we apply formulas or equations like this, many letters represent certain things in real life scenarios. For example, we use a lowercase t to usually represent time, whereas we use an uppercase T to represent temperature. Similarly, we use a lowercase r to represent rate in many interest formulas or even in the distance formula, whereas we use an uppercase R to represent revenue. And you can probably think of several other examples. For instance, lowercase d usually stands for diameter. There's lots of examples that you will run into as you take math and science courses and even business courses. Alright, so let's go ahead and look at some examples. Alright, so we have example A. We have F equals MA. And just so you know, this F here is supposed to be part of the word for. We want to solve for A. So when we look at this equation, what we want to do is we want to get A by itself, just like we did previously. And we want to figure out, okay, in order to get A by itself, I want to get rid of the M. And we need to figure out, okay, what's the operation between M and A? And this is a multiplication. So just like before when we said, okay, how do we get rid of times 5? Same thing here. We want to know how do we get rid of times M. And so in order to get rid of times M, we want to divide by M. And again, whatever we do to the right side, we do to the left. So on the right side, my M's cancel. And on the left, we have capital F over little m. And we have this is equal to A. And that's it. As soon as A is by itself, you are done. And on most of these problems, just so you know, you're not going to be able to make computation errors because we can't do any actual computations, as there will be very few, if any, numbers running around. All right, let's go over to the next one, example B. Example B, we have V equals L times W times H. And again, we want to solve for H. So for this one, in order to get H by itself, we want to get rid of the L and the W. And so here, since both of them are being multiplied, we want to divide by both. And if you want, you can kind of treat this as just one thing. We have LW times H. And to get rid of LW, well, we divide by LW. We do the same thing on the left. My L's cancel, my W's cancel on the right, and I am just left with H. And on the left, we have V over L W. Since H is by itself, we are done. All right, let's look at some other examples. All right, let's come to example C. We have L equals K divided by D squared, and we want to solve for K. So here, pay attention to what we have. We have K divided by D squared. We haven't looked at a lot of these examples, but what's the opposite? In order to get K by itself, I want to get rid of divided by D squared. How do we get rid of divided by? Well, we multiply. And so I am going to multiply D squared on the right, and whatever we do to the right, we want to do to the left. And so on the right side, my D squareds cancel. I am left with just a K. And on the right side, or on the left side, you can either write D squared times L or L times D squared. It does not matter what order they are in. And we should get L times D squared. All right. Let's kind of step it up just a little bit. We're going to come to example D. In example D, we have ax plus by equals c. We want to solve for x. So we've got a couple things going on here because we've got a couple different operations. Not only do we have multiplications, but we also have some addings and subtractings, and we've got both operations going on here. So just a reminder, this is what we are solving for. We are solving for x. Okay, so now if you recall, in our previous section, remember that our first step is we want to get all variables on one side and all constants on the other. This is where we want to pretend, okay? We are pretending that x is our only variable. We have all of our x's on the left side, which means that I want to move anything that does not have an x to the other side. So the first thing that we want to get rid of is the plus by. We are going to go ahead and, because we are adding it onto the x term, to get rid of it, I want to subtract it. So on the left side we have ax. My by terms cancel. And on the right side we have c minus by. So that is the first step. We get all of our x's together, we get all of our non-x's together, and they have to be on opposite sides of the equation. Finally, to get x by itself, I want to get rid of the a. And here, because we are multiplying a times x, to get rid of the a, we want to divide. And so I'm going to divide by a on the left, and again, whatever we do to the left, we do to the right. My a's cancel, and so I am left with x equals capital C minus capital B times little y over a. We are not going to do anything else with this here because there's nothing else we can do. So this is our final answer. It may not look pretty, but it's the final answer. Now, the previous problem that we just looked at was the general form for linear equations. And we'll revisit that formula within the next few sections. But for instance, most of the equations we're going to work with are going to look like example E. And so we will have some numbers, but we will also have some variables. And we'll have two. So here we want to solve for y. We do have numbers here, so we are going to have to do some computations, but again, it's going to be minimal. So the first thing, in order to solve for y, the first thing that I need to do is move any terms that don't contain y to the other side. And so this is going to be my 4x. Right now, it is a positive 4x, so to get rid of it, I want to subtract 4x from both sides. All right, my 4x's cancel on the left. I am left with negative 3y. And it's up to you what order you want to put this in. When we get into slope-intercept form, we are going to want the x first. So I'm going to write this as negative 4x plus 6. From here, in order to finish solving for y, we want to divide by negative 3. There's a couple different ways that you can do this. For this section, you can go ahead and just say, I'm just going to put the whole thing over negative 3. So this is what we got. Negative 4x plus 6 over negative 3. Now again, in the next couple sections, we're going to talk about rewriting in slope-intercept form. And when we do that, we are going to want to separate this. And so you can also do that here. That's perfectly fine. And if we do that, what we're going to do is we are going to take each term in the numerator and we are going to divide by the denominator. And if possible, you should simplify. So for instance, here in the first term, the only thing I can do is cancel out my negatives. And I am left with 4 over 3 x. And in the second term, we can simplify this. 6 divided by negative 3, we get minus 2. And so here you can either write the answer like this or like this. The middle one would not be allowed only because it's not simplified, and so it's not considered a great equation. All right, last problem. Let's do one more, and then we'll call it a day. And so we're going to come over to example F. We have V equals D2 minus D1 over T, and we want to solve for D1. So just to let you know, these are not exponents, these are subscripts, and they generally, what happens when you see subscripts is they're related, but they are not related computationally. They are related in terms of what are they. So for instance, you see these little subscripts when you talk about in chemistry class or biology class, when you talk about number of bacteria that's present at time 0 or at time 1 or at time 2 or at time 3. You can also see it in the formula for trapezoid, where we refer to B1 and B2 as the bases, and those are just the two lines that are parallel. But, and I'll give you kind of a hint here, when we talk about a trapezoid, is it looks something like this, and it can be any sort of configuration here, but basically we call these B1 and B2. But mathematically, there's no real relationship between these two values. So when you look at D2 and D1, the important thing is that they're not related, they are just another way to write variables. So with that in mind, we want to go ahead and solve for D1. The first thing we want to do is I want to get rid of the t on the bottom, just like before. We don't want fractions, so that's going to be the first thing I want to get rid of. You can either do LCD, or the way that I see this is I see something It doesn't matter how complicated it is, divided by t. And to get rid of divided by t, I want to multiply by t. And again, it doesn't matter what order you put this in. I'm going to go Vt equals, my t's cancel, and I am left with d2 minus d1. From here, remember that we are solving for d1, so the next thing we want to do is get any terms that don't have a d1 in them to the other side. So I want to move the d2. I am going to subtract d2 because it's positive. We get Vt minus d2 equals, we are left with negative d1. Now, I don't want to know what negative d1 is, I want to know what is d1. So what we are going to do in this case is we want to divide both sides by negative 1. And if you want, you can put the whole thing over negative 1, but I'm going to go ahead and try to make this nicer looking. I'm going to go ahead and divide each term by negative 1. And I'm going to change the signs of each term. So this is going to be negative Vt. We have minus, and we have the negative on the bottom, so that is going to cancel and become a plus. We have our negatives cancel out on the right side, and so we are left with d1. And if you want, you can write this as negative Vt plus d2. If you don't like negatives in the front, you can also write this as d2 minus Vt. Either one of those answers would be acceptable. All right, so that takes care of our solving for an indicated variable. And so now let's talk about, okay, when are we going to be, okay, so how are we going to apply this moving forward? In this class, we are going to be applying these techniques when we transform linear equations from general form, for instance, example C, and mostly example D, or point slope form, which we haven't talked about yet, to slope intercept form. At the end of the semester, we will also be using these techniques when we find inverse functions. And so they are not going to be as many letters running around, but we will always have at least the two. We will have the x and the y. Another thing that, why do we do this, is this can be thought of as an exercise in comprehending the process for solving equations. Most people do really well when we have numbers, but if you can solve an equation when there are no numbers or a limited number of numbers, if you can solve it correctly, then it means that you truly do understand the process for solving equations in general. As you progress through your math classes, you will continue to see this topic, and it's mostly just about manipulating equations and being really comfortable with the process. All right, that takes care of this particular video. We have one more video for this section where we are going to talk about inequalities.